Okay, AraBat, giving raw materials a natural rebirth. As everyone of us know, more than 11 million tons of end-of-life lithium batteries will have been generated in the next years by 2030, an incredible number. But in addition to such number to recycle, there are other problems related to the fact that today battery recycling solutions can't solve the overall problem since they are inefficient. They can recover just 70% of lithium typically on average. Such methods are expensive according to scientific publication. The typical cost to recycle 1 kilogram of lithium battery recycling in the Western world is over than €5 per kilogram. And such methods are also unsustainable with kilograms and kilograms of CO2 and other oxides emitted during the recycling. So, what if the solution to batteries, but also to other e-waste, has been right under our feet? That's the question of our startup, of AraBat. And starting from that question, we generated in the last years our innovative solution. So, that is reusing biomasses from fruit, vegetable, and also sea algae to recycle lithium-ion batteries and other waste. It's not a magic trick, it's a secret of the circular economy. More precisely, the technology we developed during the last 3 years corresponds to a revolutionary patented recycling process, a green hydrometallurgical process that includes three main stages. The first one, that is the typical mechanical pretreatment, where the battery is discharged, opened, crushed into the so-called black mass. And the second stage of our technological process is the most value-added stage. Our bio-based leaching, this chemical treatment, where we put our black mass into a reactor in contact with water, organic acids like citric acids with low molarity and concentration, and this homogeneous and heterogeneous mix of biomasses like simple orange peels from the, for example, orange juice production sector or artichoke leaves from agricultures and other biomasses that includes reducing sugars and other specific substances that cooperate with the organic acids to lixiviate the black mass and put the raw materials ion into the solution. Our final stage is a selective precipitation stage where we can recover the nickel and manganese and cobalt and finally the lithium in the form of hydroxides and the latter in the form of carbonate by changing the pH of the leaching solution. That's our process with very high performance. Just for example, we have up to 99% of leaching efficiency capability, and our current performance rates achieve up to 90-95% of precipitation rates of the all critical raw materials that are strategic resources for our countries and continents. In very summary words, we were born in 2022, and in the years we validated and scaled up our technology from lab to pilot scale. We filed 2 patents, granted one, and we are expanding our operations and starting the industrialization process. The calls to action. Now we are raising funds, the first investment round, to build our own pilot facility to put in Italy, and so to start our orange dream, to make real our orange dream. We are among the most promising startups in our sector, according to Startups Insights. And well, we are the ones who have given a biological dimension to the electrical transition, since the fate of the world may depend on a simple, beautiful orange. Thank you for your attention, and I am here for your questions.
Thank you very much, Raffaele, for the of a really interesting idea. And I see, Dima, you have already a question.
Yes, Raffaele, thank you for the presentation. Two quick questions. Are the precipitated metal salts battery grade, and have you tested them in battery like a coin cell, pouch cell, and compared with the reference? How is the performance?
Yeah. The last stage of that of precipitation stage, our raw materials currently they have, as I mentioned before, good performance rate. More precisely, our products have around 90% of purity rates. So they are ready for production sectors like metallurgy, pharmaceutical, and others. And now we are optimizing these numbers to achieve the battery grade standards because the battery sector to close the loop it requires very high purity rates, typically around 95 99%. And the next step is optimizing these last points in terms of purity rates and reusing those to create new battery cathodes. And we are working on that also from since weeks with US Research Center and other European universe to fill this last gap.
Thank you, Rafael. Good luck with this. Great job. All the
Thank
best
you
to
very
you.
much.
And Zainab, you have also a question.
Yes, so I want to say that it's a good idea. Thank you for this. But one question: how you address the pH? You said that you are an influence on the pH of some elements, and then it has an influence on the composite of the lithium or the battery that will be used or will be fabricated. So that's the question: how the pH of the elements has an influence, or how you can adjust it. Like, there are some specific tests to be done, or yeah, that's
Yeah,
my.
yes. Thank you for your questions. Very interesting point. In our case, our selective precipitation stage is made by changing the pH with salts for nickel and manganese. That is our first precipitation stage. Then we activate another pH changing mechanism thanks to the, for example, ethanol to have cobalt hydroxide, and finally, by capturing CO2 from outside, we can activate the insufflation and then the precipitation of lithium in terms of carbonate. And just two words, this stage is very important to calibrate the pH and maintaining the temperature in a very precise way because it's very important for the precipitation and the generation of the raw materials in the no in the form in the final form.